Batman has morals. Tony Stark does not.
Exactly. That's why I like Batman more, because like he actually like.
Tony Stark does in a way.
Despite loving Captain America, I don't like the Boy Scout outlook there. So I would disagree with you. I actually like that Tony Stark better than Batman.
I don't know. I grew up on Batman and like that, like and Iron Man and stuff like that. Because my brother loves Dark Knight, my dad loves Iron Man.
Alright, it's recording. Don't touch the wire, Kylie.
Yeah.
Alright, see you around, okay?
And now you're stuck with four girls.
Have fun. Okay.
It's like they're both right.
Let's go. So let's bring it back in about 5 seconds. Finish it for conversation, okay? I'm not gonna make you stop right this second, but wrap it up.
I truly do love Ben Affleck. Like he's like stepped down from Christian. Like he's the
Ben Affleck in for Harbor only.
But Christian Bale.
My historical romance side, oh, I love it.
You are a literature person.
I am.
You really are.
It's so bad.
No, it's great. It's great. And I told you,
No,
if
like,
you want to write and do publications, you need to get me stuff so I can get it to the people that put
Will you
green
read
on
it?
the map. Will I read it? Of course I will.
Like
You
how
will?
Yeah, I would love to.
Really? Because nobody ever reads
Like
it.
how
Yeah.
could you be?
All right, here we go. 5, 4, 3, 2, 1, and we're back. All right, so what you see here is the graph of a basic sine function. I can fill in the stuff if you want and put in the dots, but this is what it is. You can trust me on that. What we're going to talk about now are not the basic functions and graphing them. We're going to talk about something called an inverse function. You need to know this. As you can see up here, graph basic inverse functions. There's 3 of them. So it's kind of a thing you got to do. How this works is that when we take an inverse, okay, it flips everything. It flips your y's and your x's. So instead of having the coordinate here, what's this coordinate here? X is what? Pi over 2. Y is 1. They flip. So y is pi over 2 and x is now 1, right? It flips these things. That's kind of cool. However, this poses a problem.
Wait, what is this?
Why?
We're talking about inverse functions.
Okay.
X and y switch, okay? This poses a problem because when you take an inverse of something, you're going to rotate those, or switch those things around, and when you graph it, you're going to get multiple points from the same x. So when you plug in x equals pi over 2, you're going to get a lot of things over here, which is normally okay for a regular function. But now that you've switched it, now you've got y and you've got tons of x's. That's a problem. That breaks the definition of a function. That's all you need to know. You can't have an inverse of a function be not a function. That doesn't work. So how do we know this is going to happen? In short, okay, the thing you really need to remember is vertical line test, horizontal line test. The VLT and the HLT. If something passes the vertical line test, it is a function. When we flip something like this, if we flipped it, it would go like that. It will no longer pass the vertical line test. Let me show you. If we flip this thing right now as is, we would get this. Here's the flip version of sine of x. Something like that, okay? It's actually a pretty good drawing. So, it would be like this. Here would be -1 and 1, because now we flipped our variables here, and this would be pi over 2, etc. Do you see what I'm stepping in small when I'm stepping in here? Okay? It flips it. That's a problem because this is no longer a function. Why is it no longer a function? Because it no longer passes the vertical line test. It touches a bunch of points. We need it to be a function because otherwise we can't do algebra. If I have this, right? That's a terrible example. No, I'm fine with that. We can't solve for theta. We can't do algebra, right? Replace this with x. Get x on its own to find x, right? We have to do an inverse function. Again, if I had this, you know what to do. You what? Divide by 2 to both sides, right? You take the inverse function of what's going on here. Something times 2. Well, to undo that, we divide by 2. You can do the inverse to it, the undo. That lets us do algebra and gets this. X equals 3 over 2. We have an operation happening to x. We need to get rid of that operation to get x on its own. If we don't have an inverse, we can't do that. And you can't have an inverse if this thing can't be flipped and be a function. So we really needed that. And in order to make that work with math, we said, okay, whenever we write inverse, really what we mean is we're just taking this graph, this specific graph, and we're only looking at it from here to here. Here to there. And if we flip this part of the graph, what's going to happen? Well, we're going to get something like this. That passes the vertical line test, so that's okay. So we are restricting our x values. We're restricting our domain.
Okay, I get this, and like
Questions, yeah?
this part, but it's not after this is where you lose me. Like I get all this because I get like restricting it like as and
Cool.
like that. It's like
If I lose you, ask a question as I go along. Do you think that would work as the best method? Okay.
I'm just letting you know. Like,
Yeah.
if it's-
I appreciate that. So we're restricting our domain, our x values, right? That's what domain is. It's what x values you can throw into it before breaking math. Normally, the domain for sine is everything, right? You can plug in anything you want, right? Who cares? But now we have to just restrict the domain in order to make it work as an inverse function, right? In order for this thing to exist, sine inverse. Note that this is not the same thing. This does not equal 1 over cosecant x. Inverse is not the same thing as reciprocal. Okay? This is important. So whenever you say 1 or sine to the negative 1 or sine inverse is how we read that, do not substitute that. They are not equal. Okay? Whole different thing. Erasing this now to make room. So we're restricting our domain. Where did we restrict our domain to? Any number from negative pi over 2, not including negative pi over 2, so we're going to use this guy. This means not including. Okay? This kind of bracket means including negative pi over 2 to pi over 2. We restricted it between these 2 points. Do we see that? These 2 x values are where we restricted it, between negative pi over 2 and pi over 2. Why did we pick there? Because if you restrict here, that's the most you can take before it starts breaking the vertical line test when you flip it. Also known as the horizontal line test before you flip it. See how it breaks it? So that's how much we're restricting it to. Just this little thing right here.
Do you always restrict it the same amount?
Always the same amount. You could restrict it differently, because you're saying, well, why didn't we restrict it over here? Same dumb thing, because this makes it easier for what we need to do for math, so they did the easiest thing, the closest to the origin. So it's negative pi over 2 to pi over 2. Side note, unit circle, before we get into actually graphing. This is 0, this is pi over 2, this is pi, and this is 3 pi over 2, yes? This is positive pi over 2. This is negative pi over 2. We've restricted ourselves to only here. The unit circle is what numbers we plug in for x, right? We've restricted that we can only plug in certain numbers for x. Our domain restriction, right? Our restriction is between these 2 numbers, negative pi over 2, which is really what this is, right? And pi over 2. So we are restricted to coordinates 1 and 4. Is that important? Yes, sort of, maybe. You need to know it. Is it super important for final? Not necessarily. Okay? But you can see why we're restricted to 1 and 4. So if you ever see that, you can understand, oh, it's because we're restricted between these 2 numbers. That's all. Okay? That's all. Erase this if it's confusing you. Okay? It's gone. The bad math is gone. Okay? Alright, so now that we've restricted this, we can graph our inverse function. I told you that the x and the y values flip. So let's take our points that we have. We have this point right here, this point right there, and that point right there. It should be on the inside, right? It's not lined up well, okay? That's why I like to use smartboard, but we don't have room. We gotta do triggers. Let's take these 3 points and plot them over here. We flipped our x's and our y's. So instead of labeling our x-axis with these guys, let's label our y-axis with these guys.
On the test, are we gonna have to draw like when you ask with inverse with sine, are we gonna have to draw a sine and then do like the inverse?
No. In fact, I wouldn't even do this. You just need to know where it's restricted to,
Okay.
right? So let's do 3 pi over 2 and negative 2 pi. This will be pi over 2, positive pi, 3 pi over 2, and 2 pi. And you'll see what I'm getting at here. So now our 1 and negative 1, right, what we have for our regular sign, we're going to have that for this. This is what we're graphing over here, just so you guys know. Okay? So it has the same things here. Now let's plot those points. What coordinate does this point have? Negative pi over 2 for our x, right? And negative 1 for our y. Do we see that? It's kind of hard to see. Negative pi over 2 this way, negative 1 that way. Flip your x and y's for the inverse. Now you have negative 1, negative pi over 2. So we're going to plot negative 1, negative pi over 2. Let's plot it. Negative 1, negative pi over 2. Oh. Okay, cool. Nice. Let's plug this one. That's 0, 0, isn't it? Flip them, same thing. Let's plug this one. This one is positive pi over 2, positive 1. Positive 1, if we flip it, right? Do you see what I did there? Positive 1, positive pi over 2. And that's it. Those are the only points we can plug in. So all the points between here and there happen. So our line, our graph of this is just this line here. Why is that? Because we restricted between here and here. Let's draw our asymptotes. These are asymptotes, these red lines. So let's draw them. We had an asymptote at x equals negative pi over 2. Now we're going to do it at y equals negative pi over 2. And one at positive pi over 2 for our y value, right? Because we flipped our x's and our y's. That's your graph. That's a horrible dot. It should be right there. It's in there, right? Do we see that graph?
And what is this whole thing
That's
called
it.
again?
This is the inverse of sine of x.
Alright.
So you just
So there's that
take the
whole
graph and
process.
you flip it 90 degrees.
You do. So you can visualize it and get that, or you can look at it and think, I'm going to flip these 3 points.